Okay, hello everyone. My name is Joe Scorsone. Channel is called Ethernet Wink, and in today's video, I'm going to be doing an update to the Python blockchain I did however many episodes ago on the channel. And the reason I'm going to do this is because in me making that YouTube video about that other blockchain, I realized the amount of flaws in it. And so I made a new one. I've pretty much fixed all the problems I had and made it a lot more logical. And so in this video, I want to explain that, because if you did go onto my GitHub at all afterwards, after you watched that video, you would have probably seen at one point or another that I did update my GitHub and I put a new repository in there. Right here, I think I called it update on PY misspelled chain 3. And there's just a lot more differences in it. This one's actually shorter. It's 180 lines. The last one, I have it up here on my screen. The last one was 214 lines. So a lot simpler. A lot of things are very similar, but yeah, so I'm pretty much going to copy and paste everything that stayed the same, and then I'm going to show you guys what's really different in it. The biggest differences, I think that there are only 3 functions that are very different. Get, data, and the signing functions. I think that that is it, because my other one, I have it right here. Nope, I don't. Yep, right here. In this one, we see get data, always initialize the balance to 0. I think in this one, I have it just keep the balance at whatever it is. It's not always initialized to 0 at the start of this function. So it'll always get updated as we continue adding blocks. And here we have 2 different functions for the keys. And that's just not what we want to do at all, because then we have a bunch of, then we have sign transaction. Sign transaction, I just keep everything in here, because validate signature is valid are just very useless. We could just do it in a very simple way. Mine blocks is also different because the signatures are different. So let's get into this. It's on my GitHub. It's in the description. So if you want to just either copy and paste the code for yourself, or if you want to follow along with me, the code I'm going to copy is just totally available for everybody's access. Of course, as I'm putting it on YouTube, but you know what I mean? So here we go. And then, so I'm going to get that. And let's just work our way down from here. So next thing I'm going to do is I'm going to just make def get, there's a capital G in this, okay, get data. And all it needs is self. And in the old code right here, I had it initialize self.balance to 0. Like I said, I actually don't know if it's different besides that. I'm going to try and do a little comparison. Okay, yeah, it is different in one way or another. So let's get into it and let's change this. So first thing that we're going to say is just simply while true, because we're going to have I don't know what we're going to, that's just how we're going to do it. So we're going to say while true, and I'm going to say and equals str, just to make sure, input, and we're going to say 1 to send, 2 to receive, 3 to break. And we're going to store whatever they type in into the variable ands. Now we're going to say ands equals string 1. What are we going to do? Well, we're going to take in a from address, a to address, and a quantity. Those are just simple inputs, so I'm just going to copy and paste them again, because all this code is just in the GitHub, and a lot of it is very similar to the last blockchain I made. I actually don't even really think that this is that different, so I know that this isn't, so I'm just going to copy and paste it. So here we have the conditions for if answer is 1, That's me. We're going to be sending stuff. So from what address are we sending it? This one for mine. Who we're sending it to, the quantity, and then the opposite, kind of confirming the transaction. Who sent you the money? Enter a password or whatever to accept it, and enter the quantity of the transaction. And elif answer equals 3. We just exit the program. Next, we need to make a variable. I actually think that this is identical. Yeah, it is. This is just in the loop. Yeah, okay. This is identical. Actually, this is just in the loop in this version. So it actually is pretty identical. Then we just don't initialize balances in the start to 0. I'll go over this for you guys now. We're going to set a variable called transaction as the joined version of the from address, the to address, and the quantity, stringify the quantity. And we're going to append this transaction to the transactions list. And then if this from address was our address, meaning we sent money, we're going to subtract the quantity from our balance. And if we receive money, we're going to add the quantity to our balance. And that list is the data that we're going to use when we hash the block. Okay, and actually, conveniently, right afterwards, the next functions are the two that are actually different, sign transactions and line block. Now, I'm going to copy and paste everything that surrounds those two. So that way, we can work just right in the middle, and whenever we're done with that, we can F5 and run this. So, we got everything from import time down to the get data function, and then everything from mining rewards down to the bottom of the function. I mean, down to the bottom of the program. Excuse me, we don't have mine blocks or sign transactions. So, let's get into def sign transaction before we do anything else. This is the only function that we're going to need for these keys. And that's way better. That's way, way, way simpler for anyone, for any program. If we can do something in one function that we were doing in 5, do it. So here we go. We're going to say def sign transaction. We're going to say self. We're going to navigate directly with the keyboard. There we go. We're going to make sure that we spelled it right because it looks weird for some reason. But we spelled it correctly. Good. Okay. Now we have import ECDSA up there, so this will work well. So we're going to say self.sk. We already have these variables declared, and the initializer. I think we do. This doesn't matter if we do it. Yeah, we don't, but that doesn't matter. All right, whatever. We're gonna have self.sk equals ECDSA dot signing key dot generate. And we're going to specify the curve. So we're going to say curve equals, and we're going to say ECDSA dot S. And then we can pick whichever one we want. I'm going to go with SECP256K1. That's all we need for that line. The next one, actually, the primitives for readability. The next one we're going to say is self.theverifying key, VK, equals self.sk dot get verifying key. The outputs of both these functions are going to be stored in this variable. So this is the key we use to sign, and this is the key we use to verify that transaction. So, next thing we need to do is we need to get the hashed instance of this transaction. So, we're going to say hash tx equals hash mid dot SHA-256. If you're anything like me, you're sick of typing that in. I'm going to say self dot transactions list. And for this example, I'm just going to take the last one, because after we make a new block, we reset this list to empty. So there really should only be one in there anyway. But in the future, maybe you make some code that just joins all those strings together, all those transactions together into one super long string, and then you actually hash that whole group of transactions. But for now, let's just do it like this. And we're gonna hexadigest that. I can't type today. I don't know why, so I'm copy and pasting from my GitHub. Okay, next thing we're gonna do is we're gonna say bytes. We need a new variable called bytes underscore hash transaction equals bytes hash tx, and we're gonna put it in. I think this is CTF -8. I don't think that single quotes and double quotes doesn't matter in Python, but I don't know, just for making it identical, I guess. And we're gonna say self.sig, signature, whatever, equals the signature of self.sk dot sign, the actual signature on these bytes. And then what we're gonna do is we're gonna return. What am I doing? We're gonna return the signature self.sig and the bytes of the hash transaction. That's all. That's all we need from this function. Okay, next we're gonna get into MIME blocks. So I'm gonna copy and paste def MIME blocks and the new block instance that we made. So let's make this a little smaller. We have MIME blocks, def MIME blocks equals new block, blockchain, get index, get time, get proof of work, previous hash, data, string, 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 balance, string, string, string. If you made this in the last video, that looks very familiar and you understand what that does. Next, we're going to say that sig and id equals self.sign transaction. And if you don't know how returning two variables at the same time in the function works, since I put the commas like that, equals self.sign transaction, this variable, the first variable you return goes to the first variable you typed, the second one goes to the second one you typed, so just like that. So self.sig is in sig, and bytes hash tx is in id. I don't know why I named it id. In hindsight, that title has no relevance to anything else, but whatever, it's what I have. It's what I have my GitHub for whatever reason. So next thing we're gonna do is we're gonna say self.verify equals sk or self.vk, my apologies, dot verify sig and id. Now, in other words, this could all actually technically be in this function, but just for readability, I guess, just to make it a little procedural. Actually, just make it procedural at all because it's still in an object, so there's no point in doing it like that. This could all be procedural code. This doesn't have to be an object, which just makes it a little easier. Actually, does it? I don't know. That's a topic for another video. I think I just gave myself an idea. Anyways, what we do is we use our verifying key to verify the signature and the bytes, and this is a Boolean now. That's either true or false, depending on the status of the verification. So we're going to say if self.ver is false, we're going to raise an exception. We're going to say just bad signature. And then I spelled it out like totally. I said, what the hell is happening? Am I okay? Why is it indenting like that? Hold on. I think because I copied and pasted it, it's like indented weird. What the hell? It's just... Bear with me a little bit. Yeah, it was all indented a little funky. Okay. We got there in the end. Next, I spelled it out on the GitHub. I'll just do that again, especially so you can actually really be able to see what's going on, because you really could just do an else, because there's only two things. It's either true or it's false. So if the verification is true, what we're going to do, we're going to append it to the chain. We're going to append new block to the chain because it has a good key. And that's so, I don't understand why that is. That's very weird to me. It is all lining up. Spider's being weird. Did I just find the first thing I don't like about Spider? Maybe. But next. Yeah, because that's not lined up. That's so weird. Yeah, that's strange. Whatever. I really don't know what that's all about, but whatever. We're going to say self dot transaction, and we're just going to make it an empty list again. I don't know why that's happening. And then afterwards, just because we want to make sure that we're doing everything correctly. Oops, sorry, I just hit my microphone. And just to be able to visualize exactly what we're doing, we're going to print all these variables. And actually, what I'm going to do is I'm going to say, I'm actually going to give a prompt for this, so signature. And so like that. Bytes. Status. Why not? That's different from GitHub, but so is the indentation right now. And then we can just return. Alright, and now with that we can run our blockchain. So I think I changed down here as well. So in the main. So there you go. I think it's a little bit prettier. I think it actually is conceptually correct. I'm not sure. Yeah, it is. Actually, I don't think so. Whatever, it doesn't matter. It's in the description anyway. So we got one for due, two for end. So let's receive some money. Actually, no, let's send it. I'm feeling generous. Enter an address to send from. My address. Who am I sending it to? My school. Quantity of my transaction. Stop and dry. Okay, there we go. So now we see our signature is right here. The verification, is that what that is? No, nope, that's the bytes. Oh no. Our signature is all of this. Right there. Our bytes is right here. Our verified status is true. Signature is, I believe, all of this. Yeah, signature is all of this. And then we have the regular stuff in our blockchain. So the index of this is 1, the hash is this, balance is that's funny. Previous hash from our Genesis block is this. We could have added difficulty to our Genesis block, but it doesn't matter. And yeah, there we go. That's a little bit more conceptually correct for a blockchain. And yeah, I hope that you guys enjoy that. I'm actually just thinking to myself right now, yeah, why do I do it like that? Hold on a second. I have an idea. I do. I have an idea. Let's just say start that proof of work. And then we have the data, then we have that. In quotes, let's do 3. And let's make this 0 for infinite. I don't know, let's see what that, I really kind of just want to see if that runs. Yeah, list index, that makes sense actually, because no, it doesn't get previous hash. Ooh, wait a minute. I'm really interested in why this doesn't work now. Oh, I understand. Okay, I understand. I'll explain. I'm getting a little sidetracked, but that's okay. We got the point across the video that we wanted. So in the get hash, yeah, in proof of work that uses get hash, we have block string, and we use self.get previous hash in it. That's why that doesn't work. I could think of a way to make it work. I could get it together and put a proof of work in the Genesis block. Maybe that, and if this code is procedural versus object-oriented, whatever. This is object-oriented for some reason. I don't know why. Maybe that's my next topic. Make an object, make a procedural blockchain. Maybe that's my true calling in life. Who knows? But yeah, there you go. 180 lines. We've got rid of some empty lines right there. It's all in here. Now we have this very simple function for signing it, and we also have this very simple function for mining the blocks, and we get this pretty output. It's actually not pretty at all. It's kind of difficult, but whatever. Hope you guys all enjoyed this video. The next video I'm going to come out with, I'm going to kind of talk about the architecture of the Silicon Valley banking collapse. I think that'll be very interesting to talk about. And yeah, that's pretty much all I got for today. I hope you guys enjoyed. If you have any suggestions for what I should do next, please leave a comment. Please let me know, because I'd be very happy to hear what you guys got. I have very little ideas left for Quant Connect. I could try to... I'm on spring break right now. I could try and make Lazy Bears squeeze momentum indicator into an automated strategy. Who knows? Who knows? I'll be happy to try whatever you guys throw my way. So please leave a comment for a suggestion of what you want me to do. And yeah, leave a like and subscribe if you learned anything useful and you feel like you'd be able to learn more useful things in this environment that I made. And yeah, have a good night, everybody. I'll see you guys in the next one.